Hi and welcome to our next mini lecture on pre-calculus. The topic today is graphing an exponential function and its asymptote. The function that we have in mind can be written as f of x is equal to some number, we call it b for base, raised to power of x. So that is our function. Example that we have here is f of x is equal to 5/4 quantity raised to power of x. How do we graph that? Software says connect 5 points and also draw the asymptote. So the 5 points that you have are going to be connected by a curve, and the asymptote you have to decide if it is horizontal or vertical and draw that one as well. And that's it. So let's go ahead and pick this issue apart. So we have some function f of x is equal to some b to power of x. It's called an exponential function because x is in the exponent. So this one is called the exponent, and this is our base. The base is going to be always a positive number for us, otherwise we'll get into an issue how to raise it to an arbitrary exponent. Easiest way to start this thing is to make a table. So we have our x and then here b to power of x, and of course our friendliest number are 0, 1, 2, -1 and -2 for x. So b to power of 0, remember our base is always a positive number. B to power of 0 always 1. B to power, so the b to power of 0 is just 1. B to power of 1 is just, well, it's just b. B to power of 2, well, that's b squared. B to power of -1, do we remember from previous classes? B to power of -1 is same as the reciprocal of b. B to power of -2 is the reciprocal of b squared. So these are our 5 numbers, and all that's left is to plot them. So for example, if I have f of x is, what did we have, 5/4, or whatever the number is, 5/4 to power of x. Here are x and y's. So 0, 1, 2, this is going to be 1. This is the base. This is the square of the base. -1, reciprocal of the base. -2, square of the reciprocal. So the only challenge left is to carefully find these points on your table and do an accurate job of locating them. So your steady hand probably is going to do a better job than I will do. At 0 it's going to be 1. At 1 it's supposed to be 5/4, 1.25. So that is almost, this is 5/4. At 2 I'm supposed to be 25/16. So you find that, and 25/16 go on your calculator perhaps, or use the, so if this is 2, 25/16 is almost 1.56, somewhere around here. At -1 we have 4/5. 4/5 is going to be, so at -1 is 0.8. At -2 is 16/25 is 0.64, somewhere down here, and we have to connect them. There you see an ever slight curve here, and that's how it goes. Now if you track this function long enough, it's going to start to accelerate and increase quite rapidly. If you go toward the negative x's, the higher this power is, like -3, -4, and -5, and so on, this amount is going to decrease gradually until it comes very close to negative side of x-axis. So if you don't mind me, I draw this thing inside my table. The two, the red and green, do not intersect, even though my careless drawing here makes it look like as if they are intersecting. They do not intersect, they come close. So what we see here is this gap that is between, let me use a different color, the gap that we see between these two functions, it starts to shrink. That phenomena is called an asymptote. So this line, let me color it purple, x-axis, this is an asymptote. This is the asymptote of y is equal to 5/4 to power of x, because this gap, the gap between the asymptote and the function, the gap shrinks toward 0 as you move away from the origin. Any line that has a property that its distance from the graph of a function shrinks towards 0 as you move away from the origin is called asymptote. There are several types of asymptotes. If you have a function that comes to close to its asymptote like this, then the asymptote is called the horizontal asymptote, for obvious reason. So in this case, y is equal to b to power of x. So the asymptote of y is equal to b over x is x-axis, which has the equation y equal to 0, which is a horizontal asymptote. But it's not necessary for horizontal asymptote to be always on the x-axis. They could be anywhere. If you had a function, say looking like this, that all of a sudden it starts to shoot up, then its asymptote is going to be vertical. So this is called the vertical asymptote. We saw that in the previous lecture when we graphed a rational function. Less commonly, you come across asymptotes that are at an angle other than 90 degrees. So an asymptote could look like this. The function could come close to this, but make an angle other than 0 or 90 degrees. So this is similar to others in the sense that the gap between the function and its asymptote is approaching 0 as you go away from the origin. Sometimes this is referred to as a slant asymptote, sometimes called oblique asymptote, or words like that. We see them less commonly than the other ones because they're a bit harder to find than the other two cases. But remember the following for today. The asymptote of b to power of x is y equal to 0. Now let me just mention, sometimes let's look at another example. Suppose I have 1/2 to power of x. 1/2 to power of x, if you make a table for it, here's an x and here's a y, say 0, 1, 2, 3, -1, -2, -3. At 0 we always get 1. At 1, 1/2. 1/2 to power of 2, 1/2 to power of 3, 1/2 to power of -1. That means you have to flip your fraction. You get 2 over 1, which is just 2. To power of -2, it becomes 4. To power of -3, it becomes 8. When you graph this function, you see that its asymptote is on the right side, meaning at say -1 we are at 2, at 1 we are at 1/2, at -2 we are at 4, at 2 we are at a quarter, and so on. The graph is declining as we go toward right. So here is an asymptote 2, that meaning the gap between the function and this line is shrinking as you go away from the origin, but this is happening on the right hand side. So when you have y equal to b to power of x and the b is less than 1, as we see here, excuse me, let me write this thing. As b is less than 1, then the graph of it looks like this. If you had y equal to b to power of x, but b was larger than 1, then the graph of it would look like this. So that would be like an example of 2 to the power of x. This would be an example of 1/2 to the power of x. So let's keep that in mind as we move forward. So here you graph your function, and then you're also draw the asymptote. In this case, is simple answer. It's just the x-axis. You're going to color that or draw that as well. Okay, so that already brings us to the end of this discussion, and until our next mini lecture, good luck and God bless.